Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for the coming classes with respect to physics. This is lecture number 5 of the units and measurements. So let's begin with the today's class. Today what we are going to discuss, we are first going to discuss about the accuracy and precision. Now, what do you mean by accuracy and what do you mean by precision? How that can be determined? Let's see. So let's begin with the accuracy and precision. What accuracy is, we can say that accuracy refers to how closely a measured value agreed with the true value. That means how close it is related with the true value. While precision, what is precision? Precision refers to the what limit or resolutions the given physical quantity can be measured. Can you differentiate between this two? When we consider accuracy, we are just going to check whether by which amount the measured value is nearer or is close to the true value. So let's say true value is 7.2 and I am having a certain measured value. That's a measured value 1 and measured value 2. One of the measured value is 7.1 and another is 7.6, let's say. So now what happens? This is my true value 7.2. I have measured value 1 which is a 7.2. I have measured value 2 which is a 7.6. Which one is the more closer to the true value? So by observation we can see the 7.1 is more closer to the true value. So in these two readings, 7.1 meter is more accurate as compared to the 7.6. Can you get it? Okay, let's move to the precision. Let's suppose a true value is 7.2 meters. Again, take the same example. Well, we have taken measurement of this value by two different instruments. One of the observation, what I can get is 7.100 meter, while the other is saying 7.4 meter. So while talking about the precision, I need to observe a number of decimals after a decision. I need to check a number of decision after a decimal point. Here it is having a 3 decimals after a decimal. Here it is having only a single digit after a decision. So what would be the precise value for 7.2 meter? So number having more number of precision would be considered as a precise value. This is having a more number of values. This is having a more number of digits after a decimal. So this would be a more accurate. Can you get it? Okay. Let's take one more example. Let's say a measured value. Let's say what we say a true value is 4.2 meter and the measured value, let's say first observation is telling that it is 4.1. Second observation, it's in 4.4. Third observation, let's say it is in 4.0. I need to find out. I need to find out which one is more accurate. So what should I do is I need to compare every observation. I need to compare every observation with the true value. This is 4.1, this is 4.2. The difference is zero point 0.1. This is 4.2, this is 4.4. The difference is zero point 0.2. This is 4.2, this is 4.0. The difference is zero point 0.2. So here only the difference is zero point 0.1. Here the difference is zero point 0.1. Here the difference is zero point 0.2. Yes. And here the difference is zero point 0.2. Yes. So this two, that means 4.4 and 4.0, are far as compared to the 4.1. So we can say this is more accurate value as compared to this two. Now let's say we have been measured with this also, that my first observation is 4.100. Second observation, let's say it's in 4.3452. Another observation tells me it's in 4.8. And I have been asked which value would be more precise. So I can write this is having three digits after a decimal point. This is having one, two, three, four. This is having a four digits after a decimal. This is having a single unit, single digit after a decimal. So the number having more number of decimals would be the more precise. So this is precise value. I hope these things are clear. So while considering about the accuracy, you just need to check which one is the more closer as compared to the true value. And while considering about the precision, you need to just check it out. Which one is having more number of digits? Which one is having more number of digits as compared to the true value? So this is how we can determine which one is the accurate, which one is the precise. Let's move to the next. And we are now going to discuss about the errors. But before we go to the errors, let's find out several ways to find out the true value, how it could be determined. Let's say we have this many observations. We have, let's suppose we are measuring certain length, and to measure then that length we are going to observe it several times. Let's say first observation A1, second A2, third A3, next A4, next A5, and up till AN. We have taken this many observations. Now, what the true value is? So, what I need to do is I need to take an average value of this. How could I take an average value? I need to just simply add this A1 plus A2 plus A3 up to AN, divide by total number of samples, that is I have taken n samples. So while writing this, I am just going to add this. I can write like this. Do you know the meaning of this symbol? It's in summation. It's in summation. We call it as in sigma. So I can write like this: average value or a mean value is equals to 1 by n. It's in sigma ai, while I stands from 1 to n. This will give us me a true value. Next, absolute error. We are talking about certain errors. What are the absolute errors? So, what absolute error is? I will find out. I will find out. It is a difference of true value minus measured value. Did you remember you have taken n number of samples? So, if you want to write delta A1 absolute error in the first observation, you should write A bar. It's an A average, or you can write A minus A1, it's in first measure value. Delta A2, it's an A bar minus A2. Delta A3, it's an A bar minus A3. And so on for the delta AN, that is an A bar minus AN. This is the absolute error in each observation. So what you are going is, you are just checking what amount of error has been introduced in every individual observations. But mind well, this absolute error should be always a positive. It could not be a negative. That's why we have put it up into the modes. You know that when a certain data has been put up in a modes, when the calculation is over, they will be make a positive, and the final answer would be a positive one. So this is absolute error. Now next, look at the mean absolute error. Now what do you mean by mean? You know that it is an average only. So in previous slide, we have been calculated delta A1, delta A2, delta A3, and delta AN. So while I take an average of this all errors, while I am taking about the average of this all, it would be a mean. It's in delta A mean. So this is delta A mean is equals to starting from A1 to AN divided by n. So while I write like this, 1 by n, sigma I is equals to 1 to n and delta ai. Again, the while the all this errors are positive only that we talked in previous slides that absolute error would be a positive only. So it is obvious that mean absolute error must be a positive. So this is mean absolute error. And last, relative error. So when we are considering about the relative error, we have discussed about the delta A mean divided by A min. It's an average value. So relative error is the measured physical quantity. It is the ratio of the mean absolute error to the mean value of the quantity measured. Can you observe that it is a ratio having same physical quantity? Does it have a dimensions? Or I should rather ask, does it have a unit or dimensions? Does it? No. It is a pure number. It's a pure number which does not possess any units, any dimension. So what is relative error? It is just a ratio of the average absolute error, which we call as a delta mean, divide by average value. It's a mean value of the observed quantity. And next, move to the percentage error. This is the last. So what is percentage error? What is percentage error? We have considered a relative error. It is the relative error. So when I multiply relative error multiplied by 100, this comes to a percentage error. So relative error and percentage error gives a measure of accuracy. They will tell you that how accurate your observation is. As as you understand that as soon as percentage error increases, accuracy decreases. Because what we understood by an error is the fault in the calculation, or if it is a fault in the measurement. So as soon as the percentage error increases, accuracy decreases, and so on. So what we have discussed up till now, let's summarize. We know what is the average value, then we have discussed about the absolute error, that is the difference in each value, in each observation, and each measured value. Next, it is the mean absolute error. Next, it is the relative error. And last, it's in percentage. So this is all we have discussed until now in today's class. If you have any difficulty with this, just try and revise in your mind. Okay. So let's move to the practice questions. Tell me the measure of accuracy. The measure of accuracy. What it will be? Whether it will be an absolute error, a relative error, percentage error. Yes, if you have remember previous slide, it is a relative error and percentage error. So this should be the correct answer. Answer should be a D. It's a both B and C. Yes. Next, the difference between mean value and measured value. What is it? Did you remember this? Delta A would be equals to A bar minus of A1, or delta AN, it is equals to A bar minus of AN. This is the difference between mean value and measured value. It's an absolute error. Yes, those who have did it, well done. Keep it up. So I think these things are clear up till now. Yes. Let's move to the systematic errors. So before we go to the systematic errors, let's first define errors. What we can say is it is an amount of uncertainty in the measurement of the magnitude of a physical quantity. So whatever we are going to measure, when and when there are certain uncertainty. We are not sure about that data that we call as an uncertainty. That creates an error. So basically error is a measured value minus true value. Basically, error is always what we have calculated and what would be the true value. The difference between these two, what we have calculated or what we have measured, and what is the true value. The difference between these two is an error. Which kinds of error could be there? These are the types of error. These are the very good theoretical questions are there. In previous years, JE has asked certain questions over this only. Even two or three questions have been arised from Neet as well, while they are the conducting AIPMT. Yes. So let's look at this types of errors. Basically, what when we can segregate this into primarily three quantities. Primarily three, I can segregate this in primarily three quantities. First is the systematic error. First is the systematic error. Another is the random error. Another is the random error and last is the least count error. So they are the systematic errors, random errors, and least count errors. Now, what is systematic error? What is systematic error? There are certain incidents where error would be arise. One of the few things are the it's an instrumental error. This all comes under the category of systematic errors. So, what is instrumental error? So, there are certain times that our design is imperfect or we cannot calibrate the device correctly or there are the zero error in the instrument. Now what is it? Let's say you have been visited a sweet shop and you have asked about the 1 kg of certain sweet. As shopkeeper has not placed anything on the weighing machine, but his reading is observing that point 2, let's say point 2 gram, but he has not put anything. So this point 0.2 gram, as soon as he has not put up anything on the weighing pan, even though it is showing zero point 0.2 gram, this is an error. This is what we can consider as an instrumental error. Understood? So whatever the error that arises due to difficulty in instrument or the calibration or the zero errors due to imperfect designations, this all are the instrumental errors. Next, let's move to the personal errors that we call as in the errors which occur due to limitation of the human senses, judgment, or carelessness and responses. These errors are known as the personal error. There are certain times that we don't know how to measure. There are certain times that we don't know how to measure a certain physical quantity. And at that point of time, whatever the errors that have been arise is known as the personal. Let's say you have been taken a thermometer. You know thermometer, yes. In this case, it is very essential. So you have been taken a thermometer, and you are just measuring a fever of some person. So that means you need to check the temperature of that person. Yes. Generally, what we are using at our home is mercury thermometer. Even nowadays, digital thermometers are same, but we are using the mercury thermometer, something like this, and we just measure the indication by a mercury which has been filled in the thermometer. So if I don't know how to measure it, if I don't know how to measure it and what things to be observed, then that then the temperature that I will measure must be having an errors, and that errors would be due to personal errors. Here you need to consider that thermometer is absolutely okay, but as in person, I don't know how to measure it. So that comes into the category of the personal errors. So one is the instrumental error, another is the personal error. And next is the imperfection in experimental technique or procedure. There are so many times this happens that we don't know the exact or the correct techniques to perform an experiment. Let's say a test tube is there. I hope you know the test tube. And the observation and certain liquid is filled, which is up to this level. So correct observation should be you need to take the observation from this point parallel. If you are observing this value from this, so the rays would not be a parallel, it would be a slanted. Or if you are taking an observation from this, the rays are not parallel. So this would be the correct approach. These two are the incorrect approach. So why this arise? Why this arise? Because of imperfection in experimental technique. So this all creates the systematic errors. So systematic errors, which are they? They are the instrumental errors. If our instrument is not proper, the next is the personal error that I don't know how to take an observation, and third, imperfection in experimental technique. Now the next category is random error. What are they? These errors are random and occur irregularly. It can be due to changes in the ambient conditions like temperature, pressure, etc., or due to limitation of instruments. So all these systematic errors can be reduced by taking a correct number of observation or by having an correct correct measuring techniques or calibrating an instrument. But how could I remove the random errors, or how could I reduce the random errors rather? What I can do is to reduce the random error is need to take more number of observations. To reduce the random error, I need to take more number of observations. So let's say if I am taking 30 observations and the error would be alpha. So let's say, so if I take 150 observations, if I take 150 observations, my error would be alpha by 5. Got it? So you can make a relation that is n1 multiplied by error 1. This is observation. So b is equals to n2 multiplied by error number 2. The next error. Can you get it? Does it clear? Yes. So these are the random errors. Why they arise? Actually, we don't know why this arise, because they are first thing they are occurring randomly, and random represents that we don't know because they are the random. Yes. And how can I remove it? So exactly I don't know how can I remove it, but I know how could I reduce it. How? Then I need to take a more number of samples. I need to take a more number of measurements. As soon as I take more number of measurement, as soon as I take more number of measurement, more number of samples, I can reduce the random errors. So, and by what factor it will reduce it, you can calculate with the help of this. N1 into E1, this is equals to N2 into. So, let's move to the least count errors. Now, what is the least count first? What is it? We can consider that it is the smallest value that can be measured using an instrument that we call as a least count. Whatever the smallest value that can be measured by an instrument that can be considered as a least count. Let's say vernier calipers having a least count of 0.01 centimeter. A spherometer, even a screw gauge, has the least count of this 0.001 centimeter. You need to remember this. You need to remember this. This is 0.01 centimeter. So this is zero point 0.1 mm and this is 0.01 mm. I hope you know this. 1 mm is equals to 10 centimeters. 1 mm is equals to. So, sorry, 1 centimeter should be having a 10 mm. 1 centimeter. Let's rub it. 1 centimeter is equals to 10 mm. So, you need to remember this list count. Okay, now what is the least count error? What we can say is least count error is the error associated with the resolution of the instruments. So, it is an error that is associated with the resolution of the instruments. So, these are the least count errors. So, what we have discussed up till now, we have discussed about the three categories of errors. One is the systematic errors that can be reduced, even that can be removed. Another is the random errors that can be reduced using the help of more number of samples or more number of observations. And the last is the least count error that is associated with the resolution of the instruments. So now check it out. Having the factors by which we can reduce the least count error. First, what we can do is using instrument of higher precision. Now tell me, what is the least count of vernier calipers? For vernier calipers, it is zero point 0.1 mm. Yes. For spherometer or screw gauge, it is a 0.01 mm. So if you are having an error with this, you can go with this. This is the basic and simple example. Yes, what you can do is, let's say regular scale is there. A regular scale is there. The that we call as a meter scale. It is having a least count of 1 mm. So if you are having an error with this meter scale, you can go to the least count. You can go to the vernier calipers. If you are having an error with this, you can go with this. There are even certain other quantities too. There are even other certain principal techniques too that that are having a least count value even less than this, less than the screw gauge. So you can switch to them also. So, and the second is the improving experimenting technique. And the last but not the least, and very important, you need to take so many observations. You need to take an average value of this. While taking an average, you are just moving very nearer to the true quantity. So now we know what are the errors, why they arises, and how can we reduce these errors. Now let's move to the calculation of errors. How could I calculate the errors? So let's say this is very basic. Suppose you have taken this many observation A1, A2, A3 up to AN. What you need to do is at a very first stage, you need to find out the most probable value. That will I call as an A min. How? Then I will write it A1 plus A2 plus A3 up to AN divided by N, which is basically a mean value. So this is first step. After finding out the most probable value, I need to go to the mean absolute error. Hn. What we have written is delta A1 is equals to mode of A bar minus A1. and so on for the delta a n. This is a bar minus a n. But remember one very important thing, that mean error or mean absolute error would be would be always a positive value. So mean absolute error would be always a positive value. It's a mean absolute error. It's a, then while considering about all the absolute error, I need to take a mean of this delta a bar. It is a delta a1 plus delta a2 up to delta an divided by total number of samples. So this is mean absolute error. It's in second step. Third would be a relative error. What it would be? It would be a relative error would be a ratio of this error. This is mean absolute error that I should write as in delta a bar to the a mean. It's an a mean. And last, as in fourth stage, it is a percentage error, which is basically a multiplied by 100 to the relative error. So this is all I need to calculate. First, a most probable value, which I should say as an a mean. The second, I should find out the absolute error. That means the error in the observation of each individual value. It's a mean absolute error. The third I should find out is the relative error, which is an average of the mean absolute error and the most probable value, which is an EBA. Next, I need to find out the percentage error. Basically, a percentage error. Basically, a percentage error. It is just the ratio of the or mean error, mean absolute error to the most probable value multiplied by 100. Or I should rather say, find out the relative error and multiply it with the 100. That will give you the percentage error. I hope these things are clear. Yes. So let's move to the numericals. Go through the data very carefully. What they have been given. They have given is the side of the object measured by means of a vernier calipers is 3.52. If the least count 0.01 centimeter, estimate the percentage error in the measurement. Do you remember the least count errors? Yes. So here it is. They have given the least count is 0.01 centimeter. So error in the measurement is 0.01 centimeter. Least count number always represents an error that may have within the measurement. So this is the error. It's in 0.01. Yes. What is the measured value? It's in 3.52 that I have been written here. Now what they want me to do. It's in percentage error. So how percentage error can be calculated? It's in first you need to find out the relative error and you need to multiply by 100. Now what is relative error? If you all remember this, it is a delta y by y. Delta can be represented as a d as well. It's a dy by y. So relative error, it's a delta y by y multiplied by 100. What is delta y? What is delta y? It's an error. It's a 0.01. What is y? It's a true value. It is a 3.52 multiplied by 100. So when I solve this comes to an 0.28 percentage again. So this is my answer. Understood? Yes. Can you do this? Are you sure? So let's move to the next question. What they have been given is the side of the cube measured to be this. It's in 20.44 plus or minus 0.02 centimeter. Find the percentage change in the measurement. Percentage change in the measurement. Now, let's look at this number very carefully. When and when they have been given A plus minus delta A. When they have given a data like this, A plus minus delta, then this delta A represents error in the measurement, which we call as a mean absolute error. Please do remember this. And this A represents true value. when data has been given as A plus minus delta, delta I represents error in the measurement and A represents the true value. So you can remember like this, whatever the things that is after plus or minus sign, after plus or minus sign, it represents error. And whatever the number that is before the plus minus sign, before the plus minus sign, it's a true value. So now let's get back to our question. So here they have been given a number as 20.44 plus or minus 0.02. So which one is the error? Tell me, which one is the error? Yes, you have guessed it correctly. This 0.02 is an error. So I have first written delta y, it's in 0.02 centimeter. And which one is the true value? The number which comes before plus minus sign, it is 20.44. It's 20.44. What I need to find? I need to find percentage change, or rather to say a percentage error. So when I write a percentage error, it's in delta y by y multiplied by 100. So I have been given delta y, which is error. I have been given true value, and then I can simply just calculate it. Get it? Can you do it? Yes, very good. Now let's move to the combination of the errors. Now, what is combination of error is all about, and how this comes. Let's say we are going to add two things, or we are going to subtract these two things. Let's say we are having in two quantities, which are the A and B, which A would be an A plus minus delta I, here it is, and B is B plus minus delta B, here it is. We have measured two things, and their observation seems like this. While I calculate A, I can write it is an A plus minus delta I. While I calculate B, I can measure it is a B plus minus delta B. So first thing, what is A? It's a true value. What is delta I? It is an error in the measurement of it. What is B? It's a true value of B. What is error in the measurement? What is the error in the measurement of B? It is a delta B. Yes. Now, if I need to add this to, let's say Z is equals to A plus B, then A containing an error, B containing an error, then Z must be having an error. So I should write it just as Z plus minus delta Z. So the Z is the error in the result. So Z is the total value. Rather, I need to say Z is the total value or a true value. And delta Z, this contains an error in the addition. So if I write like this, that Z is equals to A plus B and delta Z should be written as delta A plus delta B. I am choosing delta A plus delta B because when we calculate an error, when we calculate an error, we always go for the maximum possible value of an error. So we are going to choose every time. Every time we are going to choose a maximum value within it or maximum error within it. And that can be possible with the help of addition only. So we need to choose delta Z, that should be is equals to delta A plus delta B, and Z which should be equals to A plus B. So this is the relative error, and while calculating the percentage error, I need to just multiply this. I need to just multiply this by 100. So does it clear? Yes. Now let's move to the error due to subtraction. We will go through its questions in a very next slides. We will go through these questions in a very next slides. But before we are going to next slides, let's look at the error due to subtraction. We are going to calculate A, and which will give me an A plus minus delta. We are going to measure B, which give me an B plus minus delta B. Now delta A is the error associated with it. Delta B, it is the error associated with B, and I need to perform a subtraction, which is Z is equals to A minus B. So when I calculate z, it must be having z plus minus delta z. Yes, yes. Then what is z? It will be an a minus b. What is delta z? Remember my words in last slide. When and when we need to calculate a value of an error, we always go for the maximum possible value. So what I should choose is delta A plus delta B because this is only the possibility of a maximum value. This is only the possible value of a maximum occurrence. So this delta Z should be is equals to delta A plus delta B. So whether it would be an addition, look at this, or whether it would be an subtraction, error would be the same. It would be an delta A plus delta B. While the true value here, it should be an A plus B, and here it should be an A minus B. I think these things are clear. So we have done in the combination of errors, we have done up to uh, two operations. One is the addition, another is the subtraction. Now let's check how we can use it. Let's move to the numericals and focus on it and do on your pen paper simultaneously. Let's say one value is that x, which is 40 plus or minus 1 meter. Let's say another quantity is that, which is y. It's a 100 plus or minus 2 meter. Now I have a z, which will show me a x plus 1. So I need to find out basically a value of z, and I need to find out the error in the measurement of z. It's in delta. So first thing what I need to do is I should write z plus minus delta z. This is what I require. First, I need to calculate z, which is an x plus y. Now look at this. This is a true value of a z. So this is a true value of x. This is a true value of y. What is the true value of x? Let's find it out. This is 40. This is x. This is plus or minus. So this would be a delta x. This is the correct value or the true value of y. And this is the error in the y. This is delta y. Now x and y. It is a 40 plus 100. This is 140 meter. Yes. Now what is delta z? The delta z would be error in x plus error in y. What is error in x? It's a 1. Error in y, it's a 2. So this comes to an 3. It's again delta z is equals to 3. Now our task is done, z and delta z. Now let's move to the next step. If they have been asked what is the relative error in the answer. So for the relative error, I need to do delta z by z. It's a delta z, it's a 3, it is again 40. Can I show unit as a meter? No, relative error does not contain any unit. Yes? Okay, next, what is percentage error? What is percentage error? It's a relative error multiplied by 100. So this is 3 by 40 multiplied by 100. It is a 3 by 40 multiplied by 100. So this 2 should be gone. And this is 30 by 4, which we can say is a 7.5 percentage. So this is the percentage error. Does it clear? Does it clear these things? Yes. Let's move to the next numerical. Let's say we have been given resistors. First value of resistor is 100 plus minus 3 ohm, and another value of resistor is 200 plus minus 2 ohm. And I need to find out, calculate the error in the series combination of this resistors. Before we go to the series combination of this resistors, before we go to the series combination of this resistor, first let's check it. This what is 100 plus minus 3 ohm represents. So this means its resistance can have a maximum value of 100 plus 3, which is 103 ohm, and this resistance having a minimum which is 100 minus 3, which will be a 97 ohm. So it means this resistor can have a value of 97 ohm to 103 ohm. But this could not have a value of 96 ohm anytime. This is not possible. Even it is not possible that it can have a value of 104 ohm or more than this. So can you understand what I mean? So when and when we write plus or minus, we write that this number can have a maximum value of this number can have a minimum value of this. Same way, calculate for the R2. R2 max, R2 max would be 200 plus 2, which is 202, and R2 minimum would be 200 minus 2, which is a 198. So this can have a value from 198 ohm to 202 ohm. It could not have a value lesser than 198 ohm, or it could not have a value which is greater than 202 ohm. Please do remember these things. Now let's move to the question again, which was the R1 should be equals to 100 plus minus 3 ohm, and R2 was 200 plus or minus 2 ohm. And I need to find out the series combination. So first, let's say this is R1 true value. This is delta R1 error in this. This is true value R2, and this is error in this delta R. Now I know that when I need to perform a series combination, I need to do addition of this. This is R1 plus R2. So for calculation of RS, I need to do 100 plus 200, which will give me a 300. And while calculating the error in this, it's in delta RS. I need to add error in it. It's in delta R1 plus delta R2. Now delta R1 is 3, delta R2 is 2, and this is equals to 5. This is the error in the series combination. When if they have been asked relative error, then I need to do delta RS divide by RS. It should be in 5 by 300. Okay, now do one thing from your side. If they have been asked percentage error, what it would be? Yes, you guess it correctly. It's in 5 by 300 multiplied by 100. It's in 5 by 3 percentage, approximately 1.66. So can you do this? Let's quickly do a last numerical of today's session. Let's do it. Let's say they have been given x, which is a 100 plus minus 2 kg. They have been given y, which is 50 plus minus 1 kg, and they have asked to do x minus y. So let's just mark the true value and error. This is x, this is an error, so I should write it delta x. This is a y, and this is an error in it. This is delta y. And I need to find out the relation that has been given is z is equals to x minus y. So z should be is equals to x minus y. Yes, so it is 100 minus 50. It would be in 50. Then I should find out the delta z. Now, should I write delta x plus delta y or delta x minus delta y? Now remember why there we have discussed that when we need to find out, when we need to find out an error, we always go with the maximum possible number. So that should be delta z should be is equals to delta x plus delta y. So that should be 2 plus 1. Should be a 3. What is the relative error? What is the relative error? Tell me. It's in delta z by z. It's a 3 by 50. Yes. What is the percentage error? It's in 3 by 50 multiplied by 100. So it's in 6 percentage, approximately 52 is 100. Yes. Now, will you able to solve it? Yes. Do practice a lot of questions based on addition and subtraction. Okay. So in this class, what we have discussed is we have already discussed about the accuracy. We have discussed about the precision, then switch to the errors, and we have discussed about the various types of errors. They are the systematic errors, random errors, and the least count errors. And we have switched to the combination of the errors. In the combinations of errors, we have covered up till now addition and subtraction. I hope these things are clear. Do more number of questions for the practice. The number of questions practice will give you a confidence to solve the question. So please do it, please. Okay, let's close it here. Thank you. Good day. Take care and bye bye.